Okay. Okay. Hello. Good morning, everyone. As you know, my name is Arun Timalsina, and I am a senior software engineer here at Spiralogics. So, in today's session, I will be discussing about profiling for success, enhancing software development performance through data-driven insights. So, basically, in this session we'll discuss on various ideas on how to carry out application profiling. So how to carry out application profiling to increase the performance of the application. And we'll be talking about different factors that we have to keep in mind while profiling our application. So the different factors includes, to be sure how we use our time, or how we manage our time to effectively and optimize the right areas within our application. So these will be the insights of this session. So we'll be first starting with the basic concepts of profiling, then we'll continue with their types, then we'll discuss how the data that has been captured related to a particular application, and how this data can be analyzed and used to improve the performance of our application. And further, we'll also discuss how we can develop and profiling and optimize application optimization process. So how the process, how we should carry out the profiling thing to make our application more robust and optimized. So starting with our problem statement, let's say we have an application in a production environment, and let's say we get some performance related issues. Then how will we proceed with that? How will we tackle with those problems? What will be our plan of action while dealing with such resources? So let me open one quick question up for discussion. Okay. So you can just raise your hands or send emojis. So how often have you profiled your code, or how often have you profiled your application? Why? Because application profiling is one important aspect of software development, but looks like of only few of have ever profiled our code or profiled our application. So why is it so? So it's so because many of us, including myself as well, we see profiling as an extra piece of work, right? So we have one existing workload, and if we think that profiling will just increase our existing workload. So it is not commonly as a part of our SDLC process. So many of us actually enters the old of performance and profiling only when something goes horribly wrong in our code, right? So that means in most cases, if there are some performance related scenarios uh, encountered in the production environment. So at that point, we'll receive some errors, we'll receive some, optimization related issues, memory leak related issues. And at that time, we begin to panic because we have a time limit and pressure on us at that point, right? So and at that time, with pressure on, we begin to determine to, debug our program. Um, but in fact, all these issues, most of these issues, so let's not say all those issues, but most of those performance related issues could have been identified before we proceed to our production environment, before the code was pushed to the production environment, because we have different level of environments like dev environment, staging environment. We could have profiled our application in those environment before pushing that to the production environment. So these issues, or performance related issues, would have been identified beforehand. But since we did not perform code profiling, so all those code bottlenecks, input output issues, all those things are commonly replicated in the production environment. So while facing those issues, so what is the first thing that we should keep in mind is where should we start, where should we spend the refactoring effort. So right, so there are different blocks of code. There are, thousands of lines of code. The issue may be on a particular portion, and how should we refactor that code, and how the process should be constructed to profile our application and optimize our code. So in the next few slides, we'll try to find out answer to this particular question. So along with this discussion, we'll also be discussing about the concepts of application profiling. We'll try to break down on various profiling methodologies. So we'll try to carry out an effective to try to build an effective process for profiling, and we'll also be listing out what challenges that we might face during this process. So let's begin with the basic understanding of what profiling actually is. So talking about profiling, it is a process of gathering information about a program's behavior. So especially what profiling does is it just gathers the information on how the code is being executed. So let's consider a simple program which runs in a sequence. Let's say there is a code flow which calls method A, method B, and method C. So to achieve a result, let's say for the functionality of the feature of that particular code flow to work, the code has to run in the sequence, like A have to run, then it needs to call B, then it will sequentially call C. So once that sequence is completed, then we will get our expected result, and we'll say that this code is working fine, or this piece of code has passed its functional requirement to do what it was supposed to do. But in this case, we are just more focused in the code flow, whether it has been completed successfully or not. But we are unaware of what or how the code is actually behaving like. What is the memory utilization of this code, what is the memory footprint of this code, how much time the particular block of code is taking to execute, what can be the possible bottlenecks of this particular code, or how this code can be enhanced in terms of responsiveness, in terms of efficiency, and in terms of application speed. So processing this code will help us understand how the code will flow. And the next thing that profiling does is it provides us evidence for the development. So it provides us evidence why this code block, or how the approach of how this code block was constructed should be changed. Why this algorithm, if any, applied to this particular code should be changed, or why the pattern, if there is any, why this should have been changed, or can the process be divided into multiple other code blocks or other concurrent process that can run in parallel, and so on. So profiling provides evidence for developers on what to change and where to change. So that's the main problem. Okay, so not and actually not only for developers, but it will also provide insight for resources management as well. So since it is a basis for application optimization, not only just application optimization, but for resource management, enhance user experience, bug detection, and even we can through code simulation, through while running code profiling, we have to run some kind of automation, some kind of RPAs, and through that process we can, while simulating those scenarios, we can determine how the code will behave in some stressed conditions, right? And the hidden box or unintended consequences of the code, those can be extracted uh, before those those bottlenecks or those code hotspots create chaos in the production environment. So why why code profiling matters, or why application profiling matters? So since it's collection, so as application is a collection of code blocks, right? And it is necessary to understand what is happening within that code. And code profiling or application profiling, it helps us to give insights on how the program is behaving under different conditions. So let's say what is the resource utilization is, if there are 100 concurrent requests that will be sent to a particular endpoint at the production environment, then how whether that will uh, behave as expected, or will there be some unwanted consequences. So it can highlight, so it will highlight the part of the code that have potential to become bottlenecks when application is in stress condition. So basically every application will be in stress condition in production environment, because we while while developing, we'll just be considering whether the functional requirement has been fulfilled or not, but will not be more focused on how it will behave in stress condition, how the memory footprint will be, how the object allocations will be, and such stuffs. So and not only, code profiling not only help in determining these resource utilization or how the code behaves in stress environment, but it also helps to determine the coding approach on how a particular module or feature should be developed, right? So it gives a way, or it gives insight on what kind of algorithms should be used, whether a process should be divided into different concurrent things or not, whether we have to implement some design patterns, what would be the critical path of execution, and stuff like so on. So after we understand our code, so code profiling majorly works in two units. So it helps us to profile the code in functional level, and as well as in line level analysis as well. So functional analysis, it means that we'll be more focused on what a particular function will do, right? So let's say if there is a function, if there is a code flow containing of three different blocks, A block, B block, C block, then we'll be more focused on what the traces for each individual blocks will be. Let's say how much time of what will be the highest amount of time taken by the block A to complete, and what will be the highest amount of time taken by block B to complete or block C to complete. So it will be determined in terms of function calls, in terms of function call tree, and everything like. And to pinpoint the exact location where the where the hotspot is, where the core hotspot is, we have to trace down in the line level. So it will be taken care by line level analysis. So in this figure, you can see an example of a function called trace. So that means each and every block that you can see is a particular function call, and the line connecting to different blocks, it specifies how the function is associated with other code blocks. Okay, so let's say there is a particular function. It is defined by a particular box, and the relationship between that function, how the function is being called, is being determined by the line joining the two boxes. And other things, which can be obtained from this call trace is which is the function or method that has been called, mostly or frequently in a particular code run. Let's say there is a method which adds two digit. right? So how many times is that function being called within a code flow, right? So it captures that. And other memory related instance, like how many objects are being created by that particular method. So what is the memory footprint of that particular method? So at what point the garbage collection was carried out. So all these stuffs can be seen using a calligraph or call graph trace thing. Okay, so the other important aspect of code profiling is to improve the application performance, right? So we are more focused on how the application performance can be improved and how an application can be optimized. So profiling will help us to identify the basic identify at what portion of code we have to optimize or have to be changed to identify the performance bottlenecks and inefficiencies within the code. So just like there can be DB queries, which are frequently being called. So how can we reduce the number of queries if there are more input output operations that are being carried out? So how we can decrease those, whether the number of calls for input output queries are actually required for the efficient flow of application or not, if there are any unrequired queries that are being called, or if there are some unwanted unwanted objects, if there are any which are being created while calling the methods or while running the functions or not. So similarly, it also helps for real world simulation. So since we can have automation, we can have profiling, and we can have automation side by side, so that we can know how the code will react in real world scenarios. We can check whether there will be concurrency and multi-threading related issues or not, and we can debug and isolate those issues accordingly. So depending upon how the profiling is to be carried out, there are three types of profilers. So how the data are being captured. So there are three types of profiling that can be done. So the first one is sample based, the next one is event based, and the third one is instrumentation. So what a sample based profiling does is it just captures the profiling related data in a periodic interval of time to give a low level analysis. Okay, so let's say I just take a snapshot of memory utilization while running a certain piece of code. That means at that particular interval of time, what was the memory utilization that was done while running that code. So that's one thing we can take. Or at that certain point, what are the number of objects that were created. That can be the other thing, based on what we can collect the sample. And third one would be the number of requests sent to the database at that particular snapshot. So that are all based on sample based techniques, how the data can be collected or how profiling can be done. And this gives a low level analysis. So it will not tell us which function was being called at that particular scenarios. It will just give us a high level or low level analysis and high level overview of how the code is performing. And the next is event based. So basically in event based method, the records are collected in particular when a particular event occurs. So let's say the memory allocation, the memory utilization of our code has increased above certain GB of RAM. Okay, around if 50% of the RAM, total RAM space, if that much memory is consumed by our application, then the profiler will run and it will capture the data. And at that point, since at that peak point, this will the event will trigger automatically, and it will capture and logs the information, like what was the method that was being run, how many what generation of garbage collection was being executed at that point, what was the number of allocated objects, what was the heap size at that point, and all things would be captured. But for the now for the collection, certain events have to be triggered at that point. And the next one is instrumentation sampling. So what it does, it just it calculates, or it captures all the detailed information about the work performed by the application or code base. So what it does, it captures which method was being executed, what time the what was the time taken by the particular method, what was the memory allocation before entering a particular method, and what was the memory allocation after coming out of that particular method, how many objects were being created by that particular method, what was the number of DB calls that was made by that method, or what was the CPU uses, at the processing of that method. So all these information, detailed information will be captured through instrumentation profiling. So here in the figure, we can see some trace log of, while running a code base. Let's say there are three methods, right? So A, B, and C. And if, let's say, we take we are using event based method triggering. So at that point, it will only trace the activities or trace the logs if certain events get called down. Let's say I will be more involved or more focused on seeing the memory consumption or the time taken to execute a method, or B block only. So at that point, the code has to be integrated in such a way that only while the data will be collected, the only while the B method is being called. So that can be approach. And let's say there can be scenario like while the sampling be triggered if certain memory allocation exceeds, or number of DB calls exceeds. So that's all about event based thing. And the next thing is tracing for each individual log. Let's say there is a method ABC which will be called sequentially. Then what we can do is we can just wrap those methods within a wrapper called wtrace wrapper. So that will wrap method A, that will wrap method B, and that will wrap method C. And before entering A, so what will happen is our code will first enter the wrapper. Then what will it does? It will just execute some piece of code which will collect information before entering A, and it will carry out with the assigned tasks of A. It will carry out the method, and before exiting A, it will collect some information related to how related some information related to the processing, and it will log accordingly. So in the right hand, and similarly for B, and similarly for C. So this is a simple way of how how tracing or profiling can be done or implemented within a code block. And in the right image, you can see what time was which code was executed, which method was executed, and what the execution time was taken by that particular method to execute. So with this information, we will be further breaking down how this information can be used to monitor our application to find out the bottlenecks in the further slides. So in this image, so we can see a diagnostic session. So here we can see that the selected interval of time is of 35.1 second. So right, so all the grays area is the timeline, of all until which the sample was taken, or the collection or the profiling was done. And the white section, in the middle, it shows a current snapshot, which is the area of focus. So right now, if we are more concerned about what is happening in this particular section, then we can see that, the UI thread utilization graph. We can see how what are the different, the different events that were triggered at that particular portion, and what the time was taken for that thing. So for rendering, for layout, for garbage collection, so there was some time. So the log related to these events have been captured in this particular image. So this is also an example of instrumentation sampling, since we are capturing all the events related to that particular snapshot, like the application timeline of what different events were triggered. The counters is there, which will show what is the different function counts, the method counts. The memory uses is there, which will show what the heap size is, what is the current heap size, what was the garbage collection, how much memory was freed from the garbage collection process. And there is a query section, which shows how many queries were executed for that particular snapshot, and so on. So let's now discuss about the building blocks of profiling. So based on the different data that can be collected during the profiling process, so we can just summarize how on based on what thing the profiling can be done. And the first one is CPU profiling. So the main focus of CPU profiling is to analyze the CPU uses. So which helps on identifying the functions or code blocks that consumes the most CPU time. So what are the functions or methods which are uh, which are consuming most amount of CPU time within our code block? So that's the purpose of CPU profiling, and it uncovers the hotspots, where the optimization can lead to significant performance involved improvement. Because if there is a function or method which is taking maximum CPU time, then obviously that is the core hotspot, which has to be fixed and optimized so that the performance of the application can be optimized. So for this, the techniques like sampling profilers, instrumentation profilers, and can be used. And sampling profilers, since it is a periodic capturing of data, it will just give a hint on on which methods that were executed at what point the application is taking more CPU time, and we can further. So if we are going to further investigate on that, on that particular method wise, either through function analysis or line analysis, then we have to implement a combination of techniques. So sampling profilers will not be sufficient for that. So we have to implement instrumentation profilers so that we can capture the function calls, the execution path, what methods were being called at that particular time, where when the CPU time was high, while the CPU usage was high, and things like that. And we can further break down and optimize our code. So the next thing is memory profiling. So most of the time, our application, when the users increase, our application, the memory allocation deallocation thing will not work as expected. So for this, we have to do a memory profile thing. And the main focus of memory profiling is to identify memory related issues, such as memory leaks, so excessive memory consumption, which methods are consuming more memory, if there is an if inefficient memory usage pattern. So since, whenever we create some objects, those objects will take some memory, those will occupy some memory. If we are not using those objects, then that should be captured by garbage collection. And if the process between creation and destruction is not properly managed, then it may lead to inefficient memory usage pattern, and which ultimately leads to memory leaks. And if there is high amount of code or different amount of modules, then the small bits it will combine, and it can lead to a big memory leak. Okay, it can raise a bigger problem for us. So so every function is important, every code block is important, every code block has to be profiled for CPU usage time, basically memory profiling and other things that we'll discuss in the coming slides. So the techniques for memory profiling would be heap profilers and leak detectors. So basically, in memory profiling, we'll be more focused on how the memory uses pattern of that particular code is, and we'll be pinpointing to what methods are using much memory, and we'll try to figure out which is the defected code block, or which is the hot spot, and we have to solve accordingly. So, in this image, which is a snapshot of the memory allocation of the instance byte and the memory allocation held bytes. So, for a particular snapshot, and we can see that there is a vast difference between the values in the right side and values in the left side. So we'll learn more about what these values are representing in further slides to come. So we'll discuss about this, what this table is trying to say to us, or what this profile information, how to interpret this profile information in the coming slides. So let's proceed accordingly. So this image is showing the methods and the number of counts as the user, or as we perform certain activity in a particular module. Let's say I'm opening a page, I'm closing the page, I'm opening that page again, I'm closing that page again. So I'm trying to mimic a user, who would perform certain activities at a real life scenario. So I'm opening a page, I'm closing a page, I'm opening a certain module, and I'm closing that, I'm performing certain action. And at that time, at that point, I'm profiling that thing, and I'm seeing what is the memory allocation, how many objects are being created, and what are the difference. Between two steps, so between two process that I have executed, what is the difference in the number of objects that is being created, and what should be the ideal scenario. So in any ideal scenario, the object allocation should be normally be one, right? So but from this code we can see that while performing certain tasks, the reference count is increasing, as well as the count difference of that particular object is increasing as well. So we can pinpoint that while carrying out these tasks, so these number of objects are gradually increasing. So there is some defect in that particular code or particular module, so we can pinpoint accordingly. So this image show the memory uses thing. So we can see at different time intervals what is the heap size at that particular point, and whether the heap size is increasing or decreasing. So we have to pinpoint whether it is expected behavior or not. Let's say I'm opening a particular page, and I'm closing, I'm opening. So at that point, the memory can increase at certain point, but it have to decrease accordingly, right? So whether it is, so we have to determine if the value presented by this snapshot is a valid thing or not, and we have to pinpoint using other tools if required, to locate any memory leakage within our application or not. Okay, so the next thing that we have to be more focused on is network profiling. Since the modern applications, they are communicating with different subsystems or different applications. So at any point, we have to determine what is the network communication pattern and network related performance for that particular piece of code. So the purpose of this profiling is to optimize network uses, to reduce latency, improve data transfer, and to improve data transfer and optimize the application. So for this way, we can use IO profiling, instrumentation profiling, and sampling as well, because we'll be knowing what calls or what IO calls, what database calls were made for that particular code. So the next most important thing is concurrency profiling. So since since the users will be since at a point of time there will be concurrent users who will be trying to access our application. So right, so at that point we have to focus on we have to be more focused on the behavior of concurrent and parallel execution in multi-threaded and multi-process application. So how will our if there are any parallel process within our application, how will that behave? If if one thread is dependent on the result of another thread, then at that point, if one of those thread encountered some issue, and there can be so that the other thread is waiting on the result of the other parallel thread. At that point, there may be scenarios like deadlock scenarios. There may be kill state scenarios. So we have to be focused on how the threads are behaving within our application as well. So what are the threads at that particular point which are in a running state, which are the threads that are being in halt state, which are the threads that are waiting for some other threads to be completed. So we have to capture, or we have to analyze these things as well. And the techniques for this will be thread analysis, with rest condition detection, and synchronization profiling. And other things will be file IO. Sorry for the disturbance. The other thing will be file input output. So what are the file operations that are being carried out? How long are they taking? How much data are they processing? Whether that is a required thing or not. If we are using files, then are we frequently closing that files or not? How often are we putting that file in memory itself? Whether it has been collected by the garbage collector at a specific interval of time or not. And the next thing will be database things. So which queries are executed, which queries are being executed, how long are they taking to execute. So we may have to optimize the database queries in itself, in database server itself, or it may be the issue related to the network latency. We may have to deal with that as well. So the next building blocks would be database and events. So each of these blocks, each of these major blocks which are most common in use. So each of these provide their own aspects and insights. And while determining, or while using the profiling process, or while optimizing our code, so we have to be specific on what kind of data, or on what is our objective, what are we trying to achieve. And we have to select the profiling approach accordingly. So if we are more concerned on file IO, then we have to if we have to capture informations related to file IO. If we are more focused on memory leaks, then we have to proceed accordingly. And each of these have their own aspects and insights, and the selection mechanism, it entirely depends upon what we are trying to achieve and what our objective is. Okay, so now we discussed about what profiling is, how what kinds of data can be collected, or what on what basis the profiling can be done at a general glance. So let's come back to our problem statement, and let's try to develop a process on how the profiling process can be achieved, or what should be the steps that we have to follow while profiling our application. So yeah, we have our program statement. So the application was running fine. So at some point there is performance related issues. So what are we trying to do? We are basically trying to optimize our application. So on what basis? So we will be determining that. So let's say for now, it is based on CPU time. It's based on memory leaks. Okay, so we are more concerned on utilizing the memory and reducing the response time of that particular application. So what it does optimize the application. It does decrease the it just decrease the response time for that particular request to complete. So how can this process be constructed? So this process, we can construct this process on four major blocks. So first one is collecting performance related measurements. So based on our objective. So what is our objective? Our objective is to optimize the application based on memory uses. So what we have to do, we have to capture the memory related data for that particular process. So the next thing is extraction of performance related information. So what we are trying to do, we are trying to optimize the application based on memory thing. So what we are going to do, we are going to capture the data. What kinds of data we are going to capture? We are going to capture performance or memory related data, like what is the garbage collection, what is the heap size, what is the normal of number of objects that are alive in that particular function call. And after collecting that, what we are going to do, we are going to interpret that result. And to interpret that result, what are we going to do? We are going to use a combination of visualization. We are going to use different kind of visualization things while interpreting those results. And after visualizing, what we are going to do, we are going to pinpoint what the problem is, right? So and after pinpointing the problem, what we are going to do, we are going to use that thing and change our code. So if there is a particular, if are we
Okay. Uh, I think there's been some technical glitches because I cannot see Arun Timalsina. Okay. Arun, are you back?
hello? Oh yeah.
Yeah, are you?
So looks
Okay.
like I'm having some connection issues. So
Okay, sure.
where was I? So I I guess I was just speaking at my side. So my screen is visible, right?
Yep.
So where was I before I got disconnected? So I
Okay,
was
so
in the
you are in the
process thing, right?
process. Yeah.
Okay, okay.
Use
So
of
yeah,
data.
let's just do a, okay, okay. Then and okay, so what we will be doing? So we will be interpreting those results, and we'll be using based on that results, we'll be pinpointing the hottest port location. This code have to be changed. It's okay whether is a valid a call or not, and if this can be rewrite, if those methods can be run in parallel to achieve optimization or not. So this kind of stuff will be this kind of stuffs will be falls under how the results obtained by the process, profiling can be used. So okay, so and whenever whenever we do profiling, so profiling has to be a part of SDLC. So it is not an independent process at all. Profiling, it is not an independent process. So it just provides us with some evidence on what has to be done. And this process will be an iterative process. It will be on every, it should be a part of SDLC, and which help us to determines what the to pinpoint what the hotspots are, where the problem or which are the inefficient code, and we have to make changes on that particular part according to the evidence obtained by the obtained through processing. And that is to be done through data analysis, and following a particular process, so which we have already discussed. Okay, so now let's build a process. So um, let's move back to our problem statement. So what our problem statement was to optimize this thing. So based on what? Based on CPU time and based on memory performance. So what? So the first thing that we have to do is we have to set a clear goal. There can be multiple goals, but we have to set a clear goal, for a particular type. So so what our goal is to optimize our application based on memory uses and based on CPU utilization or resources utilization. And we have to then we have to define a representative workload. So in real life scenarios, we have to use realistic data and scenarios as much as possible. So for that, we can use automation, we can use RPA through, we can configure some run delays and, based on that, we can mimic how the user will, carry out certain tasks within our system. And we can capture some concurrent requests based on that as well. So the next thing is we have to construct an representative workload. So if I am to test a particular module, let's say there is a case management or case create page, for which we have to test for memory allocation, memory related issue, and CPU time performance related issue. So what we can do is we can just automate that thing. We can configure the sampling pattern, and we have to automate that thing. It can be through automation or RPA, or it can be even through performance testing, or it can be even through load testing as well. So we have to configure that, and so that we can collect data. And the next thing is we have to establish a baseline performance. So what was the what was the time, let's say what was the memory used previously, and what is the threshold that we are going to achieve. So we have to establish that threshold point. The next thing would be finding hotspot, and how we are going to find out hotspots, or what are the things that has to be changed, what is the code that has to be changed, what is the code that has to be optimized. So it is based on the profiling process. So that means we'll be using profiling techniques so that we can collect data, we can analyze that data, and we can pinpoint the problematic line of code, and we can change. And the next thing would be iterative profiling. So that means we are so it should be a part of SDLC, and we will find the pinpoint, we'll make the code change, level change, then we'll again check if that satisfies our threshold or not, and if not, we'll again iterate that whole process until we obtain our necessary threshold value. And then and the most important thing is that the profiling approach, software profiling, is a collaborative approach between developers, testers, and ops and DevOps, right? So not only for developers, not only for testers, because most of the time the performance related impact, the monitoring thing, the alert, if there is a certain memory uses in a server, then if some alerts has to be triggered, then it is basically taken care by DevOps thing. So they are the one who are more responsible on monitoring the servers, what the application is behaving, how the application is behaving, and to change, how that, and to change the behavior of the application, the one who is more concerned is the developer, right? And to increase the efficiency of the application, to pinpoint the issue. So who is the one who is more responsible, since tester is the one who is more responsible, right? So it should be a collective, it should be a collective approach, it should be a collective approach, and it should be a part of SDLC. So we can, so in the profiling approach, in profiling, software application profiling, so these steps, using these steps, we can start profiling our application. So the next thing is so okay, so we have our problem statement, we have developed a process. So we are so we do have a list of, we already have a plan on how we will carry out that process. So and the next thing is how we are going to carry out that plan, right? So what kind of data are we going to need for this particular profiling thing. So the next thing is to to choose a matrix based on our objective. So if our objective is to check the optimize the memory consumption, then we have to collect data based on memory metrics, right? And if that is based on IO activities, then we have to collect data related to IO thing. If that is related to CPU load, then we have to choose what kind of metrics are we going to collect. And if that is a user interaction, then we have to be more specific to collect the data related to user interaction. So the collection of data is more specific to our objective. So what kind of objective are we focusing on? And based on that, we have to collect information, we have to collect trace, we have to sample the data, and we have to profile based on that thing. So the next thing is how to collect data. Yeah, the source of data can be call traces, like we previously discussed. It will just give an overview, a tree like overview of what is the number of calls made to a particular method, what is the time required to execute that method, what are the dependencies required for that particular method, and so on. So what are the references that is being taken by that particular method, and so on. And the next thing would be monitors, to periodically call to query the resources. Like if we are more concerned about the CPU utilization, then we can accordingly. The third option would be triggered by an event, so that's based on the event sampling method. And the other would be instrumentation. So instrumentation is a combination of all these methods. So it will give a bigger insight of how the code is behaving. And the other will be logs, like there can be server logs, there can be database logs, there can be error logs. So these can also be included uh, as the as the data to analyze and to pinpoint the inefficient code base. So after collecting data, so what we would do is we would just store and process that accordingly. So there will be a large chunks of data. So we have to there will be some resource overhead to to store those data, and the structuredness there, the heterogeneity of that data will be large, because the pattern how data is being stored by a certain profiler or certain profiling method can be different than of other profiling method, right? So the way how the logs are stored by a web server can be different as of a database server. So all these information should be collected at a singular point, and that has to be made available for further breakdown. And before processing with those data, we just have to filter based on our objective. So if we are more focused on query thing, or input output thing, then we may have to make more use of DB related logs, the time taken by a particular query to execute. We should use those systems. And if we are more concerned about memory thing, then we may have to use the thread analysis dump data. So after we collect those data, so we have to get some valuable feedback from those data. So how can that be done? So we have to present those data in form of traces, occurrences, and profiling measures. So it can be in terms of traces, like what is the traces, what is the number of times a method has been called, what is the time taken by that method, what are the number of objects uh, being created by that particular method, what were the objects that were destructed after a certain method was completed. So data like so on, we can generate trace related information accordingly. And the next thing would be a time series data. So we'll be using graphs or flame graphs based on time series, like during this particular snapshot, or during this particular time frame, the CPU utilization was this much, the memory utilization was this much, and accordingly. And the other would be topological. The other would be the topological thing, like what is the user, how are the user acting in a particular time, and what kind of data or what kind of modules they are trying to utilize, and what is the response time of those things, and accordingly. So all this information, this can be, analyzed. We can analyze this, and this can be used for problem detection and alerting, and problem diagnosis, and root cause isolation. So that means we are going to pinpoint on what thing or what particular method there can be a problem, or which is an inefficient code, and how those things can be tackled in the basis of the metrics that we had previously discussed, like it can be memory allocation, delocation, it can be CPU usage time, it can be IO activity, it can be database queries, and other things. So in this image, we can see the data interpreted in terms of the number of calls made to a database, the number of time taken by a particular page to load, or a particular query to return its result back, and the particular the memory consumption that was in place, for that particular thing. So this image shows time series data. It shows time series data on what was the memory utilization, what was the time spent in a particular functions in the method, and what was the number of requests made for a particular method, what was the response time of that method, and so on. It is described, it is represented as part of time series data. Executing a particular code trace. So there is a request that is being made, and for that request, what are the different methods that are being called? What are the different time frame spent on a particular method, and average memory used by that particular method? Tools that we can be used. Okay, so based on these tools, so first is the profile tools. Uh, it can be used as independent tools, or it can be used within the development environment itself. So these are some examples. And the next one is the logging and tracing middlewares. So these middlewares should be injected as part of the code. So these are tracer, metrics, trace link. And the third one is collecting and visualization thing. So for visualization, we can use other languages, like we can make use of Python, R as well, but most often we'll be using OpenTelemetry. So it's a it's a program for a visualization thing, and Grafana and Elastic Stack, we can use this as well. So once the data we can be integrated, this can be integrated as part of the development thing, or it can be integrated within the server and other things as well. Okay, so what are the major challenges that we can face, while profiling? So the first thing is overhead. So since tracing involves a certain overhead, right? So we are going to trace a particular function, then there is a time, which is required to trace the matrices, trace the data that we are going to capture, while the method run. So that overhead is added, within the program itself. So that's one of the major challenges. And the other challenges will be, choosing metrics. So though we are going to choose metrics based on our objective, but it's a major challenge on how these metrics should be captured. So what kind of data are we going to capture? And the third and most important will be the impact of optimization, optimization changes within the application. So sometimes we may make some changes, related to optimization, but that may backfire on us, or that may, that may cause another issue within that application. So with that would be the major challenge while optimizing and profiling. So the future trends for optimization is more related to AI-powered profiling, integrating with development environments, and the more human-centric development, like mimicking users through RPS and other things. So let's say there is an AI bot, we can predict based on the data that we provide. It can predict whether the particular piece of code can cause a bottleneck in the production environment or not. So for that, we have to first capture the data, based on the development environment or based on the UAT staging environment, and based on those data captured, we can construct the AI bot, which can predict the occurrence of events within our application. So here are some of the common developer pitfall, so that we can face in our day-to-day programming life. So and here are some resolutions of how that can be solved through profiling. So in the images, we can see that there is a flame graph, there is a stack trace, and there is a method call. There is a method call for high call count. So if there is any performance analysis, then we may have to trace back to the high call count, because if certain method is being called frequently, then the number of issues in that particular method may accumulate, and a bigger problem may arise. So in that case, we have to do a high call count, and the given images are the example generated through high call count profiling, where you can see the functions which were called mostly within the application. There are functions, methods which did most individual work in the particular method, and there are functions, methods which are taking most longest time to execute. So from this information, we can generalize and determine whether a particular method has performance issues or not. So we have to investigate the call trace, and we have to generate call frame graph like shown in the figure, and we have to determine why it is being called. So why, if a method is being called frequently, so we have to determine why it is being called, and based on that, we can make changes in the code flow accordingly. So the next most common thing is performance analysis. So how can we determine the slowest function? So to determine the slowest function, we have to first generate the call trace or call trace graph. Then investigating on the call trace graph, we have to determine what the slowest path is, what the slowest path within a method call is. So since a method will be called, since in a code flow, there will be different methods that will be executed, right? So in that case, we have to determine which is the slowest path, slowest method in that method call, and we have to trace down accordingly to determine the slowest function while doing performance analysis. So the next one is the performance analysis based on function and high CPU utilization. For that, we have to check the heap dump. We have to check we have to check the memory leak investigation. So the prime candidate for optimization should be the long living object. So if an object is living more, within a request, and if that is not being captured by the garbage collector, then that has to be the prime candidate for optimization. So we have to look for those kind of methods during the performance analysis with functions having high CPU utilization. So similarly, the most common thing that we normally face is memory leak detection. so which is caused due to excessive memory use and inefficient allocation or retention of memory. For that, we have to collect the memory snapshot. We have to collect the garbage collection thing. So we have to find out what the memory snapshot is at a particular instance. What are the garbage that are being collected? What are the long living instances? And we have to look for the based on that. So in the graph, you can see there are two graphs. The upper one, in the upper one, you can see that the memory is raising, and and after some method has been completed, it's dipping. So and in the next method, it is increasing and decreasing accordingly. But the memory increaseness is at a constant rate. There is no you know no there is the memory uses is not increasing gradually. But in the next image, you can see that there is a decrease and increase in memory, but along with the gradual increaseness in memory uses. So you can see that the memory is gradually rising. You can see that the peaks are in upper level as well. So from these two images, we can say that the second one, there is a problem of memory leak. So because whether the memory is being created, the memory is being delocated, or it is being captured by the garbage collector, but there is a gradual increase in memory. So it can be a possible cause of memory leakage or inefficient memory allocation. So we have to, so while doing memory analysis, so the most thing that we have to look into is the memory snapshot and garbage collection snapshot. So other main thing is, if we are implementing some publish subscribe architecture, while writing code, then at some point event will be fired by a particular class, and those event will be subscribed by some other class, and the code will flow accordingly. So in that case, what can happen is there we can get a problem of weak reference. So let's say we have subscribe to an event from class A, and the class B is responsible to publish that event. So let's say at a particular scenario, the subscriber was the publisher, the subscriber who was subscribing to that event no longer exists. It is collected by the garbage. But the one who is publishing the event, it uh, it it exists in the it still is in active state, and it has not been collected by the garbage thing. So what happens is, in this case, there will be a weak reference, because there is a reference of a class, of a next class, of the subscriber class, in the publisher thing. So what will happen is, even though publisher is not being used, the garbage collector will not be able to reclaim that thing. So in that case, there will be memory. It will not be collected by garbage collector. So in that case, what will happen is, the memory will increase, and as shown in the figure, we can see that there is instance bytes and held bytes. So instance bytes means the amount of memory allocated for that particular object, and the held bytes means the particular memory that has been held by that particular object. So which should have been collected by the garbage, but the garbage collector did not collect that thing, because it may have some weak reference available at some point. So at that time, it is also a possible memory leak thing. So we have to investigate on, if we are following such architecture, then we have to be sure on not to create weak references between the classes or objects that we are using. So there are few. Before concluding, so there are few head-ups, for optimization process. So there is Amdahl's argument, so which basically deals with how the optimization should be carried out. So let's say there are three method A, method B, and method C, and the original runtime is 10 seconds, right? And let's say we have a threshold of 8.5 seconds. So that means we have to speed up our application by 15%. So what reason should we focus our optimization on? So to answer this question, it will be answered by Amdahl's argument, so which basically tells that the performance is dominated by its most expensive region. So the fastest method, or the fastest amount of time that is taken by a method to complete, is determined by the slowest method within that code flow. You got my point, right? So if there is A method, B method, and C method, they are taking different interval of time. And if we are to optimize this code flow, then if we optimize C, which is already, which is taking 1 second. So if we are to improve C, then to get a 1 second reduction in the total code flow, or the total performance of this code, we have to improve C by 100%, which may not be possible, right? So so if we are going to optimize, then from where do we have to start? We have to start from the worst method, or the method which impact the most in the code flow. So, so secondarily, if let's say if there are concurrent process, right? So there are multiple processes that will run in parallel. So in that case, so if we have multiple running concurrent process which runs in parallelly in same amount of time, then what we have to do is we have to try to decrease the critical section of that particular code. Because in the image we can see that there are four processes: P0, P1, P2, P3, and they have the P2 have the lowest computation time, whereas P0 has the highest computation time, right? So P1 will complete first, sorry, P2 will complete first, P1 will complete first, and P3 will complete then. But to complete the whole code flow, they will be waiting on P0. So there is a time where they will complete their tasks, but they will be waiting for the process P0 to complete its work before the code flow can be completed. So in this case, what we have to do is we have to be more focused on critical path to decrease the time of the most time consuming thing, or the overall critical path of that flow should be taken care of, should be considered while optimizing this kind of codes. Okay, so to conclude with this session, so we have discussed about application profiling concepts. We discussed about the methodology for initiating application profiling, how the profiling process should be implemented, and we discussed about some case study and developers pitfall for different conditions like memory management, how the performance can be increased, how the bottlenecks can be resolved. So we discussed about all these things, these concepts in this session. So I hope you had a nice understanding of how profiling can be included in within our SDLC, and I hope you will be using profiling more often than now.